Okay, so let's see if we can outline the next obvious steps. We wanted to be able to get some data back into our audio system from our ECG. We know about the ECG data. It's simple double precision data which we can read in. Do you all know how to read in double precision data from a file? You want a little lesson? You need a lesson. You gotta have a lesson. Okay, that's good. That's good. I'm glad you asked. So what I'll do here is, how shall we do that? Oh, I know. Let's write something from scratch. I was going to start with a given code, but I'll just here we'll just make a new example, and we'll give it a name. How about test data reader? We'll make our own little data reader for ECG data. That sounds like fun, right? Because who wouldn't want to be able to read data? Well, just about everybody. So I'll make a little main method, and then what I'll do is I'll get a file name. File f equals, I guess alt enter, file, Java IO file, equals feudal.getRead file. Okay, fair enough. And then alt enter will give me the feudal, and then we'll get a read file, and what we'll do is we'll prompt the user, select ECG file. How's that? And then what we'll do is, just for fun, I'll print out the file, and let's see what happens. Run. So I'll get my ECG file dialog box. I'll navigate to the file. I hit open, and there is a fully qualified path name to my file. I can copy it, and now instead of making a GUI that requires me to select a file, what I will do is I will bypass the GUI and hard code the file name, new file, and and quote and paste, enter, and so now I got a file. Now I did that because I don't like to have a graphic user interface as a pop-up as part of my debugging, because if I'm going through a long debug process and I have to keep navigating to a place in the file system, opening the file, clicking on the file, that just gets in my way. So what I did was, here, let me rerun my little episode here. I created a graphic user interface with a standard file open dialog box by calling Futal, which stands for File Utility. That's part of my own utility, and I call get read file. And then that gives me a prompt, select ECG file, which could be a part of my analysis program, generally speaking. But in this particular case, I would like it not to be part of my debug cycle. So what I'm going to do is hard code the file name so that I can proceed to start to work with it without having to get an annoying standard file open dialog box. So what I did was I hit run. I selected the file, I hit open, and then I printed out the file name. Then I copied the file, mouse right copy, and then I went into my little program, and I typed in file equals new, file f equals new file, and then I put in double quotes, and then I put in paste, and the double backslashes were automatically inserted by the IDE. So my IntelliJ integrated development environment is smart enough to know that when you use cut and paste and you have a backslash, that it escapes the backslash by adding an extra backslash. How's that grab you? Good, right? So now I got a I created the ECG file when I ran the ECG application. So if you're looking to recreate it, you would go to Bio, ECG, ECG application, mouse right on ECG application, hit Run, go to Generate ECG, click on the little icon doodad that says Generate System, and then click on Save over here on the lower right corner. Select where you want to save your ECG file, click Save. I'll overwrite what I had, and then it says blah 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 blah, save successfully, OK. How's that grab you? Good, right? Now if you wanted to, you could go and change your EKG parameters any way you like and then apply them. Brian, you got a question? Is it working okay?
Everything but Generate ECG is working.
Okay, here, let me run through it again, just so that you can see it all happening. I'll, oops, disconnect. So what I did was I went to Bio, ECG application. You got that far?
Yeah.
You got that far.
Yeah.
So you mouse right on it, you hit Run, and you got a little dialogue thingy, right? You got this far, right?
Yeah.
So then you go to ECG, Generate ECG. You got that far?
This doesn't pop up.
It does not pop up. Oh.
They always have this.
Yours doesn't work either? Anybody else have this problem?
Which problem?
This apparently is not popping up. Yours works okay? And then I clicked on the little icon that says Generate, and then it generated. Are you getting any errors in the background? Like if you bring up the console, do you see any exceptions?
Yeah, that's the one.
Oh, well there you go. What kind of exceptions? Give me a hint.
This unresolved compilation file.
Unresolved. It sounds like it didn't compile cleanly.
Yeah.
Did you get a clean compile on the code?
When I ran it, it said there were errors, but I didn't see any errors.
This might be something we need to do offline. Let's see if we can't fix that. Meanwhile, what I can do, just for a good time, is I could upload the data file so that you could have it. Maybe that's a band-aid patch. You should be able to run this code. I mean, but that, you know, there are a couple of ways we can do it. Let's see if we can't figure out what's wrong with your install. But
You're not using IntelliJ,
No.
oh, you're not using IntelliJ?
yeah, I have a lot of the same problems also because your source code and stuff gets all messed up when you load it into Eclipse, right?
Oh, are you using Eclipse?
Yeah, so what I did is I copied all your source over, and then I imported all the drivers.
Oh. Yeah, I haven't tried Eclipse. I would have to give that a whirl. You had troubles too?
Yeah, using Eclipse instead of the
Well, okay. I gotta say I rely heavily upon code that I've already written in my toolbox to make these things happen quickly. If I didn't have to rely on my code, I'd have to write an awful lot of detail extra code. So I have what you might call helper applications. So like reader utils dot get as get file as string array. That's a good one. Takes the whole file and reads it in as a big array of string. And so if I put F in here, oops, I should be able to set it equal to a string array. maybe add exceptions to the method signature. And now I have an array of string which represents the file, print utils.print, and I can probably print out the entire string all in one swell foop. Maybe a print line would be good. Let's see if that works. And there's the data. Such as it is. Yes, sir.
One question. Under this Extragram program, one of the menus there's a thing to open double from CSV. Would that also help us?
It might. It might. But I don't think that CSV file's been conditioned for this yet.
I was just wondering. I can't
Yeah.
run it, that's why.
You can't run it?
No, it's the same error.
You're getting the same error. You're just having trouble building my code under Eclipse. I guess I'm not that surprised. I haven't really tested this under Eclipse. So you're suggesting that maybe there's a shortcut and it says open double from a CSV.
Yeah,
That sounds like fun. You suppose that will work? Because we have 3 columns in this CSV, right? That's probably not going to work right away. I would say, yeah, bad things happened, right? Because you're trying to assume there's a number there, and you're reading in commas, and then there's all this extra stuff. I mean, if you said to me, I had nothing but numbers, would that work? It might do. I mean, you'd have to condition it somewhat, right? I mean, I was sort of thinking, oh, we'll write the program to condition it ourselves. But if you were of half a mind to do it on your own without having to write the program, in theory, you could use something like, uh-oh. It's trying to print it. No, don't print it. Delete. 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 So now I think there's a nice way to save. How would you do that, I wonder? Save as? So call it ECG, I guess. Uh-oh. Not compatible. Wait, do you see what's the answer here? Yes. No. Yes. Help. No. Yes. No. Oh, too late. Don't save. Yes. No. Ah. Okay, so then CMD, enter, and let's see if I can find my way over to the data. Oh, it just got a whole bunch smaller, didn't it? Let's see. Emacs ecg.csv, enter. Yeah, it looks like an array of numbers. But it's still not quite right, because we know that this array of numbers is supposed to vary between -1 and +1, right? So it still needs to be conditioned. Also, it's not being sampled at 8 kilohertz. It's being sampled at 256 hertz. So if you wanted to make something that actually worked at 8 kilohertz, you'd have to put in a lot of interpolated samples. Right? You'd have to build like a sample and hold that worked, you know, the extra numbers in. So let's see now if you can get your little theory to work. We'll just do open double from a CSV file. And now, I think maybe, wow. I don't think it's quite right, because look what's going on in here. Well, it's sort of got something going there. Let's put the log scale in. Power spectral density. Do create. Yeah, it's not right. That just looks like noise. And he's assuming an 8 kilohertz sample rate too. I guess we'd have to change the window size somewhat. Yeah, you see, you got to pad out all the numbers. You got to restrict them so that they're correct and within range. You really have to condition the data. And naturally enough, if you tried to play this data, I don't think it would play very well. Actually, that's not bad considering what we did. It's kind of an interesting artifact. So you still got a lot of work to do here, I'm thinking. And if you ran this program and you started to read in the data, you can see the data has effectively been read in and printed. Not only that, but I dare say that each one of these strings that you could read in could be interpreted as a double precision number. Let's test that theory. Double D equals S of I dot, oh, I think it's this way. Double dot to string of D of I. So what that will do is it'll parse. Oh, I better give this another name, huh? How about V for value? Oh, and here's the string, S. Okay, any other bugs? I think that's it. So let's get rid of this, and now we'll try and put in, what's his problem? He's unhappy with something. Oh, it's double dot parse double. That's what I wanted. Okay, we're good. Let's print out the value. And let's see how that is. Yep. So now I've got no problem making an array of double. Double D array equals new double of s dot length in size, and now maybe D of I equals V. How's that? So now I got an array of double. So in theory, oscilloscope panel dot show, I forgot what it was called. Wasn't it called show frame or something? Oscilloscope panel dot show frame. Copy, go in here. Oscilloscope panel. I had an oscillator panel. So we'll do that. Show frame, you put in your double data, and then you import the class, and then you run, and what does that buy you? Hey! That kind of looks like what it's supposed to be, right? Right? It's a heartbeat. So I have successfully validated my ability to read this in. It's all good, right? It's a heartbeat with noise, which is just what you expect. Pretty good, actually. Now, if you wanted to make audio data out of it, double D-O-U-B-L-E, double audio EA equals new double audio of D, and parenthesis, Alt Enter, and now I think maybe you can renormalize it. DA dot normalize, and now after normalization you should be able to show the data again. DA dot get data, and it's supposed to vary between 0 and 1. So this is 50 volts per division. 100 volts per division? It must be millivolts. Yeah, I don't believe the scale on this. That must be millivolts, because if that were 100 millivolts, 10, 20, no, so something's wrong. That shouldn't say 100 volts per division. That don't sound right to me. My scale must be wrong. Let's try and graph it somehow. I've got a graphing program which could graph it, or I could just find the minimum and maximum. DA.get max. Let's print the max. S out Control J, and we'll print the max. Quote max equals end quote plus, and put in the end parenthesis and then the semicolon, and you tell me, does this... Yeah, the max is still 1.2. Oh no, here's the max, 0.98. Just what you'd expect. Disconnect. Now let's get the min. S out, Control J, enter. Quote min equals end quote plus da dot get man, and what does that buy you? Min is minus 0.36, so that's all right. And then it was something about oh right, we wanted to play the data. So how shall we play it? ULaw codec. ULaw codec ULC equals new ULaw codec, and we'll put in the data, da.getData, and then ulc.play, and then this is not going to sound like anything, right? Because we are still working with 256 samples per second, but assuming in the ULaw codec that we have 8,000 samples per second on our sample rate. So we still need to interpolate the signal in order to stretch it out so that it looks like a proper signal. Right? But that's okay. That's kind of what we'd expect. So now what can we do about the data in order to pad it out properly? we have to go from 256 samples to 8,000 samples per second. This is giving us 256 seconds of audio. So if what you want to do is get 256 seconds of audio out of this, then what you need is to have a total of 8,000 times 256 different samples. Does that sound right? So if you, if you really want to do this, you're going to be making quite a lot of audio. What if you just did this in, what if you just made 1 second of audio? 8,000 samples. 1 second of audio. How would you do that? I'm not going to do your midterm for you. You have to do it. It's your midterm. You have to do it. And you're not allowed to sit like lumps on bumps. Because if you do, you won't get anything done. I guarantee you. Arodi, any ideas? Yes, sir.
If it's 8,000 samples per second and we want just 1 second, we'll just use 8,000 samples.
Alright, so let's create 8,000 samples. That sounds like a very fine thing. So here's 8,000 samples. We'll call this data double, I'm typing my name, D-O-U-B-L-E, double, what shall we call it? Interpolated data, ID, and so it'll be an array, and we'll say equals new, double of 8,000, and then we'll run through the array. Integer I equals 0. Maybe we should, which array shall we run through? We'll get where our original data, double, this will be the original data, we'll call it OD, original data, equals DA dot get data. It's fair. And now how are we going to make the interpolated data? We'll make a for loop, huh? For integer I equals 0 while I is less than the original data dot length I plus plus. And now I got my original data, and I want to copy it into the interpolated data. So ID of I equals original data of I. And I guess I have to do this 256 times, right? So I've got to have an index for the interpolated data. I guess I need an integer for that. Integer interpolated data index. Set it equal to 0. So here's the interpolated data index, and now what? I gotta make 256 copies, right? No. How many copies am I gonna do? Let's see. 8. I gotta get my little calculator again. The only calculator I know how to use. So somebody tell me what to do now. I got 8,000 samples per second versus something like 256 samples per second. So that means I gotta copy the input data 31 times before I go to the next original sample. And then I gotta go and copy that 31 times. So I need like a for loop in here that's gonna run 31 times for integer I guess I can't keep using I. K equals 0, while K is less than 31, K plus plus, and then IDX plus plus, because that's going to keep moving ahead, right? And then after that's done, I will increment to the next thing, and so on. My only problem is the original data is much longer than the interpolated data. So maybe I should use id.length. So let's think about this. The original data is going to increment much more slowly than the interpolated data. And what we'll do is we'll grab onto the original data sample and we'll hold it for 31 samples. And then we'll advance to the next sample. So what we've done is we've built a digital sample and hold that interpolates linearly for 31 samples before it goes to the next sample. Does everybody sort of follow along on this code? Yes, sir.
Shouldn't it be OD.length?
Well, OD is going to be much, much longer than ID. OD is the original data. And that was my first reaction. Maybe it should be OD.length. But since we're taking only a subsection of the original data, I figured the actual limit is the shorter of the two arrays. So what's going to happen if you take 256 samples per second for 256 seconds is you're going to have 65,536 samples. And then if you take those and multiply by 31, you get some big number. So now what I'm thinking is let's use the smaller of the two numbers so we don't have an array out of bounds exception at runtime, I'm thinking. So I might be wrong here. I mean, in the sense that I have a bug or something. So you might be right. But instead of using da.getData, I'm just going to use the interpolated data, ID, and see if we got a second of audio data for us to listen to. The other thing I probably ought to do is find some way to visualize my interpolated data. And for that, I'll use my little oscope panel, and I'll take my interpolated data and use that as my input. And now I think maybe we'll give this a try and see if there's a bug. And there is. So I got an array out of bounds exception, and I think that must be right here, index plus plus. So it should probably have some sort of a break in here. Let's do index. I know what to do, and I know just how to do it, because we've got a traveling window that goes 31 elements at a time. Well, let's just say if, oh, I know, IDX plus plus, if IDX is greater than interpolated data, or greater than or equal to interpolated data dot length, then break. That'll get me out of that innermost for loop. Now where should it break to? I think it should break out to here. So let's break out to there. Right? It shouldn't just break out of the inner loop, it should break out of the outer loop. So I put a label on the outer loop and called it to break out, and told it break out. Just stop what you're doing because you're going beyond to the end of the array. It's the moral equivalent of a goto in Java, but it's structured because there's a label. Huh. Well, that looks pretty ucky. Actually, it looks like I've got one cycle. Yeah, that's what I wanted. It's a little rough around the edges. It's not too bad. What if we wanted a little extra? Can I do a little extra? How about if we do, like, I don't know, 10 seconds of audio? That should work, right? That's a lot of data. Well, I don't know, RAM is free, right? I can hear it. It sounds like a heartbeat. Oh, this is cool. Can you hear it? You can't hear it so good from where you're at. Here, let's do something about that. It's still not very loud. Shoot. You know what I need is I need a speaker. Just I'm gonna steal one. Well, it's not exactly stealing. I work here. Let's just make sure I got this right. This is like working. I'm very surprised. Especially since people were casting aspersions on my code. Now, let's see if that works. That's very nice. Paddles! Clear! So that's got, you know, a lot of noise to it. But that's okay because you can see the noise, and it was actually added in deliberately. And you can sort of hear it, and you can see it, and everything. So that's pretty slick. What do you think of my code? Is it too icky for words? Can you guys do it better? Yes, sir.
When you change the ID to 8,000 to 80,000, your inner for loop is still going from 0 to 31?
Yeah, because I'm doing a sample and hold for 31 cycles because I'm only sampling my original data at 256 samples per second, whereas what I wanted was data that would be going in at 8,000 samples per second. So I had to re-quantize the or resample the input data. So I basically upsampled.
And you chose 8,000 hertz because
8 kilohertz is the standard sample rate for ULaw data.
okay.
And I knew I was going to use ULaw data for trying to realize this through the speaker. So I just decided to use ULaw data and resample for ULaw. At this point now, I feel like my algorithm has been validated on a couple of levels. The first level is the visual level. It looks kind of like an EKG. The second is the oral level. It kind of sounds like a heartbeat. So now I feel like, you know, I can sort of trust that my resampling algorithm works okay. Now you might make a compelling argument that this shouldn't have been 31. That in fact, if we brought up our little calculator and did the computation again, to go from 8,000 hertz to 256 hertz, whoops, 8,000 divided by 256 gives me a number that isn't exactly 31. It's 31 1/4. So should my index have sort of kept track of my quarter so I don't skip a sample every 4 samples? And if I do, what will that code look like? Or should this be, instead of 0 to 31, maybe it should have been 0 to 30? Oh, because that's exactly 31. So maybe that's better. Will it sound a little different? I don't know. I don't think I can tell. It definitely sounds real noisy. So, but that's okay. It's kind of what we expected.
What if you made your inner loop? I guess no.
I mean, you tell me. You guys you can run with this idea and do it any way you like, I'm sure. So now, next step, and we're out of time, but it's okay because it'll give you an opportunity to explore this during your midterm for the coming week. Next step is to do the short time Fourier transform in order to be able to create the spectrogram. So now you've got your audio. You've seen the spectrogram in action. Now you've seen your input audio file, and by the way, you have complete control over the parameters used for creating the EKG. So when you go back and run the EKG, you can change things like how much sound, what do we call it, noise there is. So if you want, you can turn the noise all the way off. So like here's the EKG application again. Let's change the parameter. Now somewhere in here there's a spectral characteristic thingy, and it should give us something about noise, I think. Doesn't it? Seed, deviation, amplitude of additive uniform noise. So if you wanted to make that something like 1, apply, close, EKG generate. That's a lot of noise, right? That's like a ton of noise. So if you wanted to redo it, EKG parameter, and change your noise to 0, apply, close, and generate. Now it's a nice clean waveform with no noise. So you have the ability to synthesize your EKG with as little or as much noise as you like. And since it's additive white noise, you have perfect knowledge of the noise model, which means you can use your Fourier transform to remove the noise, because you know exactly what the signal frequencies are that you're interested in, and you know what the noise models are. If you wanted, you could proceed to isolate only those signals which are of interest and remove the noise, which is kind of cool. You can make a bandpass filter just for the frequencies used for the different waves that create the heartbeat. So that's kind of neat. We haven't talked very much about the heart, but the heart is just a pump. But of course, you know, saying the heart is just a pump is like saying the brain is just a computer. And it doesn't really tell you very much. But the basic idea is that you have these valves, and you can hear them opening and closing as the chambers of the heart compress and also relax. And that's what you're seeing here when you're looking at this EKG. And there's a whole analysis behind all of that, and we can talk a little bit about it, but not now, because you guys have to think in terms of the signal processing aspects of all of this, which is kind of interesting, I think. Are there any questions about this midterm? How shall we write this up, this most excellent midterm? I think we have to, for the sake of those who are not here. Although we could just leave them guessing. But that'd be mean. We don't want to be mean. So I guess we'll call it a test or an assignment. let's call it an assignment, but it'll be a midterm assignment. So that way you can do it just the way you've done it before. And let's call it the midterm assignment. And as I write this up, you guys, stop me if you think maybe I've gone a little too far. Create a ECG in a CSV file using the bio.ECG application. Okay. Write a Java program to condition the input signal, I'll call it the signal, so that you can, 1, hear it, and we've already done that part. 2, see it, perhaps with an oscope panel. And then 3, analyze it. Oh, I know. Compute and visualize the, I'll call it the spectrogram. Spectrogram of the signal. Create a Word document that contains your screenshots. Can you guys paste an audio file into your Word document? You know how to do that? If not, then what we'll do is record your audio to I'll say, how would you like to record the audio? An audio file. I'll leave it to you. An audio file for me to hear it. You can, by the way, you can always do a ulaw.save AU, and it'll save an AU file directly, so you don't have to record it. And what else? Upload your code to a Blackboard. Upload your code. I'll just say upload your code. You figure it out. Please submit everything using Blackboard. Right, so when I say upload your code, if you decide you want a zip file, make a zip file. If you just want to upload one file at a time, upload one file at a time. I don't care. Whatever floats your boat. What do you think, guys? Is it clear? We've gone through this enough so that I think you guys... Mike, I'm getting a furrowed brow here.
I'll answer your question.
You want to ask after? You want to ask now?
No.
I'm going to hit submit. Okay. Oh, how about, when is this due? Next week. This is due... Today is the 21st. On the 28th of October at 2 p.m. Keep in mind, this stuff is like 10 points per day late. 100 points is the maximum. Availability, make available. Allow unlimited attempts, so you can upload more than once. Due date. shoot. I'm having slide bar issues here. Due date is going to be 2 p.m. What else? Hit submit. Submit. Okay? Everybody good with this? Alright, so what I'll do here is I'll hang around and do a little extra help for anybody who has more questions about all of this good stuff. And I thank you for your attention. Enjoy the rest of the week and drive safe, drive often.